Okay, let's look at stoichiometry. What is stoichiometry? Okay, stoichiometry is all about quantity. Okay, if you have something, how much are you going to make? How much are you going to use? Okay, so it's quantity. The steps to writing a balanced chemical equation, I just took the steps we talked about in class and I condensed them into super short form, so don't panic. Step 1, you always have to start stoichiometry or stoichiometric calculations with a balanced chemical equation. It has to be balanced. Okay? Next, you're going to write the amount of moles on top. We talked about that as being the known. Those are things you know even before reading any sort of question, as long as you have a balanced chemical equation. The givens are the numbers or the what is in the question. So when you're looking for the givens, like how many, right, or what, anything that is about the question, that becomes your variable. Now remember, stoichiometry is all about proportional math. So you need ratios. So you need at least 3 knowns and 1 x that you're trying to solve for. Okay, now 4, I just really simplified, check units. If they're not the same units, you have to convert moles to mass, moles to liters, or energy, etc. Okay, 5 is the actual setting up the proportion correctly and calculating. And 6, we're talking about stating your answer and actually explaining what the number is for with the proper units. So we're going to use this equation to look at all the different forms. We're going to look at this equation to talk about all the forms. Now, we did this equation in class. This is propane. We talked about this, okay, in burning in the presence of oxygen to create carbon dioxide and water. And it actually creates 2,220 kilojoules per mole, which we'll need for the question at the end. Okay, but let's just focus on this part for now. So let's balance this chemical equation. Let's balance this chemical equation. Okay, so we have 3 C's here, we need 3 C's here, and 8 H's, so we need 4 here. Okay, and then how many oxygens do we have? 3 times 2 is 6, plus 4 is 10, so we need a 5 here. Okay, so 5, 3, 4, and 1. Okay, that's our balanced chemical equation that we're going to use in the entire, the rest of the video. Okay, first one we're going to look at is mole to mole. So the question starts, how many moles of carbon dioxide is produced when 10 moles of propane is burned in excess oxygen? If I write out my equation again really quickly, that should be a 3, that should be the 8, that should be the 5, and the 3, and the 4. Okay, put what I know on top. I know I have 1 mole of propane will burn, need a ratio of 5 moles of oxygen to produce 3 moles of carbon dioxide and 4 moles of water. Okay, that's my known. Underneath, I want to put my given or things that are in the question. So how many moles of carbon dioxide, how many always is my x, moles is my unit, and 10 moles of propane is right here, 10 moles. Now I do my check. Mole over mole over mole, mole over mole. I can now proceed with the question. So I'm going to set up the math. Okay, so it starts with 10 moles of propane, and then in my conversion brackets, as I call them, you want to put the ratios or the knowns. Okay, the knowns are the only things that go in the brackets. So, and then I want to get my answer is how many carbon dioxide, right? So moles is CO2. So what's the relationship between propane and carbon dioxide? Okay, so if I want carbon dioxide on top, I have to put it on top. So 3 moles of carbon dioxide and 1 mole of propane is my relationship, so it's just an easy 10 times 3, so I should be able to produce 30 moles of CO2. Okay, and that's my answer. You want to state the compound at the end always with your answer. Okay, next one. Okay, now we have mass to mass, so as soon as you see mass in the question, you know you have to convert and do an extra step, right? So how many grams of oxygen is required to produce 100 grams of water. Okay? I'll write my knowns on top again. This will never change when we're doing this video because we're using the same equation all the way, balanced chemical equation all the way through. Underneath, how many grams of oxygen? Oxygen's here, grams, and 100 grams of water. Water is here. This isn't really realistic. You wouldn't measure water and oxygen in grams. You'd use liters, but whatever. We'll just do that for this. Okay. So now I look at my question. I have mole over gram, and I have mole over gram. I'm going to need to change the 3 moles, or pardon me, the 5 moles and the 4 moles into grams. And I know you know how to do this, so I'm just going to do it for you. Okay, so we have 159.9 grams of oxygen and 72.08 grams of water. Now we're just going to do our calculation and figure out how much oxygen was needed to produce 100 grams of water. Okay, let's look at a mass to mole problem. So the mass to mole problem, you're given a mass and you have to determine the amount of moles that are going to be produced or consumed. So how many moles of propane? So I have the question written on the mole ratios on top. So X moles for propane and 300 grams of oxygen, right? I'm going to put under the right one, right? Okay, so I look. Mole over mole is fine, and then I have mole over gram. That's not okay. So I have to change my 5 moles of O2. We're just going to cross it out, and I have to change it to grams. We did that in the previous problem, and that is 159.9 grams. So 5 moles of oxygen is equivalent or equal to 159.9 grams. Okay, now I set up the question. So 300 grams, I draw my brackets. 300 grams came from O2, so I have to put O2 on the bottom. So my 159.9 grams goes on the bottom. And I want my answer to equal to moles of propane. So I need my equivalent to propane on top, which is 1 mole. So this just becomes an easy division question. So 300 divided by 159.9, and I get 1.876 moles. So if I were to turn that into a different number, I would just have maybe 1.9 moles. Or if I was doing it properly with scientific notation, it would be 2 moles of C3H8. Okay, so 1.88, 1.92, whatever. I'd accept all of those, but this is always the best answer to keep the right sig figs. So let's look at volume now. How many liters of carbon dioxide will be produced? How many liters will be produced from 30 liters of propane? Okay, so we have our question. I wrote out our balanced chemical equation, and we just have to remember that 1 mole of any gas at STP is equivalent to 22.4 liters. Okay, and we'll talk about what STP is in our gases unit. So how many liters of carbon dioxide? How many carbon dioxide liters will be produced from 30 liters of propane? So I have to think about this. Do my same steps as before. Mole over liters isn't the same unit, and mole over liters isn't the same unit, but thank goodness I have a way to equate them. So if I have 1 mole of propane, I would have 22. Let me write this in a different color here. If I had 1 mole of propane, I would have 22.4 liters. And if I had 3 moles, I would have 3 times that amount. So 3 times 22.4 is 67.2 liters. I check. I have liters over liters now, and liters over liters. Now I can set up and do the math. So I have 30 liters of propane, and I want to remove it, so I'd have 22.4 liters, and I want to have on top the 67.2 liters, and I want to make it equal to X amount of liters of CO2 gas. I'll type this in the calculator. It's 30 multiplied by 67.2, then divided by 22.4, and I get 22.4. Oops, no, that's wrong. So if I do the math right, I get 90 liters of CO2. Look at is exothermic versus endothermic. Okay, so it's exothermic because the energy is on the product side, meaning it is given off. So how many moles of propane is required to produce 15,000 kilojoules of energy? So how many moles goes here, and I have 1 mole of this, and I have 2,220 kilojoules, and I'm going to put underneath that, I'm going to put my 15,000. Okay, so kilojoules are almost all the problems you'll see in grade 11 are the same units. You don't have to worry about converting units. Okay, so let's set this up the same way. The number that is given in the question, so 15,000 kilojoules. We know we need to remove the kilojoules unit because at the end we want moles of propane. So the kilojoules have to go on the bottom, and the things in the brackets are always from the known side, and on top is just 1 mole. And you get an answer of 6.756 ... or you could just write 6.76 moles of propane, and that's your answer. So technically the endothermic, exothermic are probably the easier ones to do. I hope this video helped you, and good luck.